Hey everyone, welcome back to The Explainer. Today, we are jumping straight into the advanced agricultural science behind the impact of chelated fertilizers on crop growth and quality. We're going to unpack how these molecular tools go way beyond traditional farming methods to optimize yield, boost market value, and actively protect our soil. I am absolutely pumped to share this data with you, so let's just get right into it.
Okay, here's a quick roadmap of what we're covering today. First, the dilemma of traditional fertilizers. Second, what are chelated fertilizers? Third, their impact on growth and quality. And fourth, a real-world case analysis of EDTA mix.
So before we get into the heavy chemistry, we really have to understand the stakes here. The big question is, how on earth do we achieve high-yield farming without paying a massive environmental tax? As we push for higher extraction from our existing arable land, we desperately need scientific innovations that can bridge that gap between aggressive production and long-term soil sustainability. Because honestly, we simply can't afford to degrade the soil just to feed a growing global economy. It's a huge balancing act.
All right, Section 1, the dilemma of traditional fertilizers.
Historically, relying heavily on traditional inorganic fertilizers has, inevitably led to disrupted soil chemistry over time. Constant, long-term application of these basic nutrients causes some pretty heavy environmental degradation. But contrast that with advanced chelated fertilizers. Research from the Chinese Agricultural Science Bulletin actually highlights that these alternatives offer distinct structural advantages. It's a complete shift in agriculture from, just dumping raw chemicals onto a field to utilizing a highly precise, highly sustainable nutrient delivery system. It's a real game changer.
Moving on to Section 2. What exactly are chelated fertilizers?
By definition, chelated fertilizers possess a very special structural specificity that makes them perform exceptionally well, especially for high economic crops. Think of chelation almost like a tiny molecular claw. The fertilizer literally grabs onto a metal ion, essentially wrapping it up tight and protecting it from reacting with other competitive elements in the soil. This highly specialized structure ensures the plant absorbs the nutrient exactly when it needs it, and that is absolutely crucial when precision and efficiency are literally everything.
Which brings us to Section 3, the impact on growth and quality.
Looking specifically at the growth aspect of our main focus, the impact of chelated fertilizers on crop growth and quality, the academic data shows they do incredible things right beneath the surface. They don't just improve the physical appearance of the plant, they significantly increase the chlorophyll content. And this is the crucial insight here. A better rate of photosynthesis means the plant becomes a highly efficient engine. Turning more of that sunlight into energy directly translates to a massive boost in overall crop yield. Basically, you get way more food and better food from the exact same seed.
Now let's shift over to the quality half of the equation. The research shows biological upgrades totally across the board. We're seeing enhanced vitamin C, boosted proteins, and crucial trace element retention, all alongside optimized nitrate-nitrogen levels. And when we talk about increased soluble solids in the ag world, what we're really talking about is a sweeter, way more robust taste in your fruits and vegetables. Plus, better storage quality literally means a longer shelf life at the grocery store before that produce goes bad. This right here is where advanced chemistry translates directly into high consumer market value.
All right, let's wrap this up with Section 4, a case analysis of EDTA mix. Moving from all this theory to a tangible, real-world product, EDTA mix perfectly illustrates this science in action. As you can see, before it ever even hits a farmer's field, it exists in these distinct forms. On one hand, it can be manufactured as a pure, intensely green powder, or it can be processed into these densely packed grayish-green granules that are ready for immediate application. This is exactly what the physical manifestation of precise crop nutrition actually looks like. Looking at the practical specs pulled straight from the manufacturer's analysis, a standard 5,000 kilogram batch boasts a highly reliable 2-year shelf life. And this next part is absolutely crucial for advanced soil management. When mixed into a 1% solution, it holds a really stable pH of 7.7. That proves this isn't just some wild experimental concept, right? It's a predictable, highly scalable tool designed specifically for massive agricultural logistics and reliable day-in, day-out field application. The exact chemical recipe making those growth and quality indexes possible is incredibly precise. Lab results confirm a highly targeted payload of chelated trace elements. We've got iron at 4.2%, zinc at 5.1%, manganese at 2.1%, boron at 2.1%, copper at 0.5%, and molybdenum at 0.2%.
This highly specific nutritional matrix is exactly what allows these high economic crops to safely boost their yield, completely crank up their chlorophyll, and maximize vitamin C, all without devastating the surrounding soil chemistry.
So, it leaves us with this huge question. How could adopting specialized formulas like EDTA mix transform the agricultural economy and crop sustainability in your own region? By really mastering the impact of chelated fertilizers on crop growth and quality, we can produce sweeter, longer-lasting, and significantly higher-yielding crops. And if we can pull this off while actively protecting our soil, well, the ripple effects on local economies and global food security are absolutely massive. Keep asking questions, keep learning, and I'll catch you in the next explainer.